Bismillahirrahmanirrahim. Assalamu alaikum. So now we will talk about shifts and reflections for quadratic function or squaring function f of x equal to x square. So first we will be talking about the shifts on this f of x equal to x square. So you know how to plot this function f of x equal to x square. With the help of this function we will learn how to plot a new function g of x equal to x square plus something, let's say plus 2, how to plot g of x equal to x square minus something, let's say 3, and some other function maybe h of x equal to x minus 3, why always 3, 4 square, or some other function h of x equal to x plus 1 whole square. So with the help of this function we will plot these. So what is happening here? So what will we do? We will shift 2 units up to the parent function, 2 units up, vertically up, 3 units vertically down, and 4 units to left or right. Okay, right, 4 units right side and 1 units left. So let's do these. So let's plot these. So we know how to plot parent function. So I'll be plotting my parent function with dotted lines. Consider this graph f of x equal to x square. This is my f of x equal to x square. This is the parent function. Now I'll be plotting one by one. Then I had function g of x equal to x square plus 2. So I just need to move 2 units up, 1, 2. So this is going to be here. So this is 2 units up. Now this function is g of x equal to x square plus 2. And then we had function g of x equal to x square minus 3, I believe. So you just need to move down 3 units to your parent function, 1, 2, 3. So here. So this is, moving down 3 units to the parent function. So this is, sketch of x square minus 3. And then we had defined another function that was, let me use this, h of x to be x minus 4 squared. So this is, 4 units to the right. So 1, 2, 3, 4. Here, it will be here. Okay, let me plot this way. Oh yeah, it doesn't look like symmetric to this, but okay, fine. So this is, h of x equal to x minus 4 squared. And then we had the, because so it's 4 units to the right, and then we had h of x to be x plus 1 square. So it is 1 units to the left. Parent function is here, so 1 units to the left is here. So this will be somewhere here. Okay, so this way. So this is going to be h of x equal to x plus 1 square. We can show these on Desmos to be more clear. This here, our parent function, which is f of x to be x square. Then we define g of x to be x square. If you remember, it was plus 2, so 2 units up. And then we had this function minus 3. So this was here, and then we had x plus 1 or x minus 4 squared. So 4 units to the right. Then we had 1 units to the left, and that was the x plus 1 squared, if you recall. So 1 units to the left. So this is how you can plot all of these functions just by knowing one function, which is f of x equal to x squared. Then we talk about the reflection. So reflection about y-axis, if we talk, then for y-axis our f of x is equal to x square, and if we replace x by minus x, so this is going to be x square same. So reflection about y doesn't make any difference, so it remains same. So only that is the interesting part for the parabolic function or the quadratic function is reflection about x-axis, or this function. Reflection about x-axis, that is, if you have this function x square, then its reflection about x-axis is defined by minus f of x, which is minus x square. So now we need to plot this h of x equal to minus x. So what will happen? It will be the reflection of this parent function about x-axis. So if you recall, the parent function was like this. Now we need to reflect this about x-axis. So the reflected version about the x-axis, so this part will be reflected like this, and this part will be reflected like this. So this is the graph of h of x to be minus x square. Now if you are asked questions like so vertical and horizontal shift, vertical plus horizontal shift together, you can answer questions. For example, if you are asked to plot this function f of x equal to x minus 1 square plus 3, so what will we do? So it's x minus 1, that means we will shift the parent function 1 units to the right and then 3 units up. So this will be, so this is my parent function here. I need to plot this, so I will shift this 1 unit. So here I will have a new plot 1 unit to this, and then I have to move 3 units up, 1 2 3, let's say here. So the graph that I need to plot is here. So its vertex is moved to this 1 comma 3. Our one parent function is x square, so you move it 1 units to the right here, and then you move it 3 units up. So this is the required function. On the same lines, if you are asked to plot this x minus 2 square minus 5, so what will you do? You will shift your parent function 2 units to the right and 5 units left. 2 units 1, 2 units here, and then 5 units down, 1 2 3 4 5. So it's going to be here like this parabola passing through this. I know it's crazy, but but I hope you will plot better than that. So that's just an idea. Then one last thing, you can even be asked to plot this function f of x equal to minus x plus 1 square minus 3. So what we are going to do basically, first we will reflect, then we will shift 1 units to the left and then 3 units down. So let's reflect. So this is the parent function, reflection here, and then 1 units to the left here, and then 3 units down, 1 2 3. So it will be somewhere here. We can get the idea. from Desmos as well. So this is going to be minus x plus 1 square minus 3. We can see it on Desmos as well. It is f of x equal to minus x plus 1 squared minus 3. That's here. You can compare this. So what has gone, how it did happen. So let's explain this. So we had a function f of x to be x square, which is parent function, and then we reflected it minus x square, and then we kind of shifted it 1 units to the left, x minus 1 squared, sorry, x plus 1 was there, and then finally we kind of added 3. So we get to here from parent function. With the help of parent function we can plot this function. So far so good. We are going to meet in the next session where we'll be taking another function and we will be applying these transformation. Don't forget that the shifts and the transformation and the shifts and the reflections are the rigid transformations, meaning that the shape of the function doesn't change. But if we will be talking about non-rigid transformation, there we will see that the shape does change. Thank you.